Hi, this is Mrs. Finning again. We're going to look at questions 48 and 49 of your Semester 2 Final Exam Review. And these are solving logarithmic equations. And you know they're log equations because you see log in the equation. So whenever you're solving log equations, your first goal is to get a single log on one side. Or if you have logs on both sides, you can get log equal to log, or you want log equal to a number. Okay, so since in this case I have a log plus a log equals a number, so I want to get it down to a single log equal to a number, and so I'm going to use my log properties to combine my two logs together. So remember, anytime you're adding two logs, what we're going to do is we're going to multiply the value that comes after log. Okay, so that's going to become a single log, still the same base 6. And what I'm going to do is I'm going to take what follows the log and I'm going to multiply them together. So I'm going to say 3 times 5x plus 2. And I put the 3 out front simply because it's by itself, and I want to make sure that I distribute it properly. Okay, and so that's going to equal 2. So now that I have a log equal to a number, I can use exponents to eliminate the log. So to use an exponent, what I'm going to do is I'm going to turn the whole log statement into the exponent, and I want to use an exponential base that matches my log base. So since my log base is 6, I'm going to use an exponential base 6. So I have turned the left side into 6 to the power of log base 6 of 3 times 5x plus 2. Now if I do something to the left side, I also have to do it to the right side. So I'm going to turn 2 into the exponent 2. So now the right side becomes 6 to the second power. Now, if you remember back to when we learned about logs, anytime you have an exponent base and a log base that match, they cancel each other out, and we're going to be left with whatever our exponent was. That's basically the definition of logarithm. So I'm left with 3 times 5x plus 2 because the log base and the exponent base matched and canceled. Over here on the right-hand side, that's 6 squared. Let me rewrite it so it looks a little better. 6 squared is 36. So now I have a basic algebraic equation with no log or exponent at all. So it's going to be pretty straightforward to solve it from here. Okay, so the first thing I'm going to do, I could distribute the 3. So I get 15x plus 6. You could have also divided by the 3 there and gotten rid of it all together. Okay, so now I'm going to solve for x, subtract 6, which gives me 15x equals 30. And the last step is to divide by the 15. And you're going to see we're going to get a nice whole number value. So x is going to equal 2. And that's your final answer on that one. So again, if you have two logs on the same side of your equation, combine them together using your log properties. If you're adding, you multiply the two values. If you're subtracting, you divide the two values. Okay? And once you have the log term by itself, then you're going to use the same exponential base as your log base to be able to cancel the logs out. So let's go ahead and look at question 49. So you notice I only have a single log term, but there's a whole bunch of other stuff on the same side as it. So kind of similar to how we were doing the exponential equations, I want to get this log piece by itself before I can use my exponential property. Alright, so I'm going to get rid of the 11 first. So I'm going to subtract that. That's going to give me 3 natural log of x minus 1 is equal to 5. Now to get rid of the 3, I'm going to divide by 3. Which gives me natural log of x minus 1 equals 5 over 3. Now, I don't like to deal with a whole bunch of decimals, so I'm leaving 5/3 as 5/3. Okay, so now I can see that I have my exponential term by itself. And so in order to get rid of the natural log, I have to use the exponent base that matches. Natural log's base would be e. So I'm going to take e to the power of natural log of x minus 1, and then I do the same thing on the right hand side, which would be e to the 5/3 power. Okay, so e and natural log match bases, so those cancel out. I'm going to be left with x minus 1 on the left hand side. I'm going to have e to the 5/3 power on the right hand side. You are going to need a calculator to figure this one out. The last thing I need to do to get x by itself is add 1. So I'm going to add 1 to that. So what you're going to put in your calculator is this right here, e to the 5/3 power plus 1. Make sure you use the key that says e to the x. If you just try to type e to a power, it doesn't work. Alright, so if you put that in your calculator, you're going to get x is approximately equal to 6.294. And that is how you solve log equations. get the log term by itself. Sometimes you just have to do a little bit of math to make that happen. Sometimes you have to combine two logs together. And then once you have the log term by itself, use the same exponential base as your log base. Turn each side of the equation into that base's power, and the exponent base and the log base will cancel out, and then you'll be left with a somewhat regular equation to solve.